So bear with me, we're going to do a video, just a review of finding proportions in a normal distribution, and as well as finding percentile ranks in a normal distribution using the z-scores. So as you can see, I have up here population mean of 70%, so we're going to assume that there was an exam and the population average was 70% with a standard deviation of 12. So this is our basic information. It's based on a normal distribution. So the first question would be, what's the proportion of students? So what proportion of students obtain 85% or better? Obtain 85% or better. The first thing I do always is draw that distribution and shade where I'm looking for. This helps you so that when you do the math, if you make an error, or if you're looking it up in the unit normal table, it's going to be obvious if you have drawn this based upon what we're looking for. So here's my distribution, and right down the middle is my population mean, U equals 70, and we're looking for the proportion of students who obtain 85% or better. So 85% is going to be over here because right at 70 is the 50th percentile. So I'm just going to draw a line. It doesn't have to be a perfect location because this is all just used for a visual aid to be able to locate things within that unit normal table. So here would be our x equals 85%. And we're looking at the proportions of students who obtain 85% or better. So we're really looking for all of this area. And we're looking for P, okay, the proportion. So we're looking for this area specifically. To be able to find P, we need to have our Z. Okay, so to get our Z, we're gonna need to use our Z equation. So X minus mu over standard deviation. Well, we have our X, which is 85. We have our population mean, which is 70. We're going to put that all over our standard deviation, which is 12. Okay? When you calculate that out, you should put a parentheses around this. You should be getting Z equals positive 1.25. So we have that information. So we can erase our question mark and put 1.25. Now this makes sense that it's a positive because a score of 85 is higher than the mean. So the mean is a Z of 0. If we're to the right of the mean, that means it's a positive Z. So now what we need to do is locate that proportion. So this is where the drawing comes in handy because this tells us right here that this area is in the tail. So what we need to do is look in our textbook and specifically in your unit normal table, and it's impossible to show this up close under these circumstances, but if you look, you're going to look up Z. So only column A has Z scores. So we're going to find 1.25 in the Z. So I'm going to find that in the third Z column on page 526. And then I'm going to look for the area beyond Z in the tail, which is column C. That's this area right here in column C. So 1.25 Z score, I should be finding a proportion or probability of 0.1056. So now I can actually erase that, and it's 0.1056. So that is the proportion of students that falls at 85% or better with a mean of 70 and a standard deviation of 12. Okay, so that's the first example. I'm going to try a different example for you, and I'm sorry that this is choppy. This is the best I could do. So we're going to look for, very specifically, percentile ranks now. So this changes things just a little bit. So let's say, what score would we obtain if we were in the 25th percentile? So what score falls at the 25th percentile rank? Okay, now 25th percentile, that's a percentage, okay? And we're looking for a score. So we can kind of go x equals, we don't know what x is, but we know we're looking for at the 25th percentile, which is a p-value. P equals 0.25, because we would move that decimal over 2 places to the left. So we want to find that score. So let's draw our distribution. Okay, here's our mean of 70. Now right at 70, a mean of 70 is the 50th percentile. As we go lower, the percentile gets lower because we're looking to the left. Remember, the definition of percentile rank is the proportion or the percentage of scores that fall below a certain point in a distribution. So at the 25th percentile, we're looking like maybe somewhere down here. So this right here, we're going to say is 25% of the distribution, which is P equals 0.25. So if you notice, that is in the tail. So again, we're going to look for in the tail, but we don't have a z-score. So that's what we have to do. Now we have to work backwards. We need to use proportion to find z. We need z. To find z, we got to look up our proportion. So since how our proportion is in the tail, we're going to find our unit normal table. And now instead of looking up z, we're going to look in the column C in the tail and try to find the closest thing to 0.25. So I'm using 0.2486. Oops, sorry, that's the wrong one. See, that's easy to do. Column C. It was close, but not close enough. I am going to use 0.2514. So that really is probably the closest to being straight up 0.25. And then I'm going to move over to column A and find that z-score. So that z says it's 0.67. The problem with using just 0.67 is that doesn't tell us that it's below the mean. We need to make sure we put our negative there, because it's actually a negative 0.67, which is our z-score, telling us that that 25th percentile boundary is below the mean. So with that being said, we're gonna use this z to find our raw score. So we can use our raw score equation. X equals the mean plus z times the standard deviation. So we're gonna do 70 plus negative 0.67 times 12. So when you multiply these together, that's going to be a negative that's going to be subtracted from the 70, okay? So if you were to calculate that out, you should be getting, let's do it really quickly. So I'm going to do 70 plus, and then I do parentheses, negative 0.67 times 12 parenthesis, and I got 61.96 is the score. So now we can erase this. X equals 61.96. This is your answer. So right at that location is the score of 61.96%. That makes sense, right? Because the mean is 70. And we know that the 25th percentile is below the 50th percentile, which is where the mean falls. So our raw score that we're looking for should be less than the mean, to give you kind of an idea of how that works. So let's try one more briefly, and hopefully this will give you enough idea of how to work through some of these hybrid problems in case you're struggling and you didn't understand your notes. So let's say we have, if a score of 90% was obtained, what is its percentile rank? So now we're looking for the percentile rank of a score of 90%. Okay, remember, based on our definition, that is going to be everything below. So we know the mean is 70. 90% would fall above that. So we're going to say 90% is over here. X equals 90. Everything below is percentile rank. So we're including all of this plus all of this. There's a couple of different ways that we can do this. We know that all of this is 50%, right? Because this is the 50th percentile rank right here. So we can find what this is and add it to 50% is one way. And I'll walk you through that way first. So first we need to find the z-score. Okay? So we need to use our z equation, which is x minus mu over standard deviation. Excuse me, I'm making sure that we're still recording. We are. Okay, so we have 90 minus 70 divided by 12, okay? We plug that in. We should be getting a z equals 1.67. Now that's a positive because it's on the right, okay? Now, what we could do is find this from the mean to z here, which is kind of this chunk, just this proportion. That is specifically going to be in your column B of your unit normal table, in that proportion. But first we need to find the z-score in our column A. So find 1.67, and that should be on page 527. And we're going to look up column B. You should be finding 0.4525. So this is 0.4525. Okay? That's just that area right there. But we want to add that to our 50%. But remember, we could add it to 0.50, or we need to convert this to a percentage. So if we just take out that percentage and make this a P, we add those two together, now we're looking at the 95.25 percentile rank. Or I'd be okay if you just gave me the 95th percentile rank to kind of clarify that. So that's how you would work that problem out, looking for percentile rank when it's above the mean. Using the mean to z. There is another method, okay? So we could look at, I'm just gonna redo this really quick. We know that our x is 90%, our z is 1.67. We know percentile rank is everything below, okay? But we also know the distribution has 100% in the entire distribution, which is equivalent to p equals 1.00. So is what we could do, this is all that's left over from the percentile rank. We could find out how much of the proportion is here and subtract it from 1. So if we look up in our unit normal table, so this is that other method I was telling you about, and we find 1.67, but this time if we use column C in the tail, we would get 0.0475. So P equals 0.0475 is in just this area here. Subtract that from 1 and you should be still getting 95.25%. So there's a couple of different ways of doing that. So hopefully this gave you an idea and will be helpful on your hybrid. If not, please give me feedback either way. This is the best that I could come up with because of using the textbook so much back and forth, but this at least gives you some support. Please email me any questions that you may have.